Hello, and welcome back to another video with It's Dr. Dan, and today we're going to be looking at math skills to ace chemistry. In particular, we're going to be looking at the world of percentages, especially in how you can use them in different unit conversion and word problems. We use percentages in chemistry very often to show concentration of different substances, whether it's masses or as volumes, and we also very commonly will see it in the lab in the form of different percent yields as well. So we're going to be going through a lot of different examples to help us understand this concept further, so that way you can do well in your chemistry class. The first thing though is, before we do anything, is understanding really what the true meaning of a percent is. Which, if you look at that word, when you hear percent, well, that per, right? It comes back again as it did in dimensional analysis. That is a conversion term. So whenever we see a percent, it tells you that this is going to be out of 100. So this is in itself a big fraction term where we are going to have it some kind of number out of 100. So whenever we see this, we're going to go through many different examples of how we can show how a percent is out of 100. So think a cent, like if you think of cents as in money, or cents in century, right? 100. That will help you remember that. So let's dive into many examples of how we can utilize percents. Percentages are going to come at you in a couple different ways, two main ones to be specific. One is going to be decimals to percentages. Whenever we see a decimal to a percentage, that means that we have to multiply it by 100 in order to get it into its percentage form. So for example, whenever we see a decimal, let's say if I have 0.373 as a decimal, well, all we have to do is remember to multiply that by 100, and that will show us that we have 8%, right? Sometimes we're given it in the form of a percentage, meaning that we can divide that number by 100 to show the same general idea. So let's say if I have 94.2% is the term given to me in a problem. Well, if I divide that number by 100 to make it a decimal or make it a usable number for ourselves, we could quickly see that, okay, that's going to be equal to 0.942 in decimal notation. So this can come in two different ways. We will also see a very common term known as percent composition, meaning that when we go through this, well, it's telling you it can be by mass, maybe by volume, mass over volume. But the whole idea with any percent is that it is the amount of something or the part of something over the whole. In this case, we're going to be referring to mass. So if I have the part of the mass divided over the entire thing, well, that's a percent. One way to look at that is if you think of maybe a slice of pizza or some pizza, for example. If I have an entire pizza and I just want one slice, well, a slice, there's usually 8 slices in a pizza, right? So if you do 1 divided by 8, that's telling you a percentage, right? Not necessarily in mass, but it's still a percent, part over the whole. So in this case, when we do mass percent, this is a very common thing for us to figure out how much of a specific compound or molecule is within our substance. So how can we exactly interpret that? Well, if I have the following example here, where if I say I have stainless steel, which is an alloy, meaning it's made of multiple metals, and it's made up of the following elements: chromium, nickel, molybdenum, and iron. Stainless steel is 22.4% nickel. So how can we try to define this as a fraction for ourselves, or a decimal, right? So this case, we're given a percentage. So if we go from percentage to decimal, meaning that it's part over the whole. Now, if you also remember percent, right? We have a bunch of little things that we have all swirling around our brain. Well, being that this is a percent, the way that we can end up determining what is our part in this case is going to be, we have 22.4%, which is the same thing as saying, oh, I have 22.4 grams of nickel. But remember, percent, so out of 100. So we have 22.4 grams of nickel, all out of 100 grams of stainless steel. So we can show this as a fraction, not only just as a decimal. We could convert this to a decimal. If you do 22.4 divided by 100 in your calculator, you will quickly see, like how we did earlier, that this will be 0.24 would also be your number for this case, right? If you wanted to know exactly what it was in terms of a decimal. So it's the ratio that we have here. But this is something we can use for ourselves as a very helpful conversion term. Let's do a bunch of examples with this. So when it comes to trying to define these in different problems, sometimes you might be given a problem like this one, which says if magnesium chloride, so MgCl2, contains 25.5% magnesium by mass, and the mass of the compound is 213 grams. What is the mass of magnesium? So with this one, there's many different terms we are given here. So what we have to do is define our givens, just like a dimensional analysis problem. One thing that we are given is we have a percent, right? We have 25.5% magnesium. And one of the first things we can do for ourselves is define that percent, because it is a conversion term in disguise. So when we have this, it is 25.5 grams of magnesium. And it told us that the problem told us the compound is MgCl2. So that is our whole, right? 100 grams of MgCl2. Great, we have our fraction. That's the hardest part, defining what that percent means. Now, what else were we given in the problem? We were also told that our compound is 213 grams. So we'll put that down as well. So MgCl2 is 213 grams. Our desired piece of information is that we want to know what is the mass of magnesium. So what we have to do is set this up like a unit conversion problem. So how can we do that? Well, we have two options to start with, either the mass of magnesium chloride or a unit conversion. And if you remember from previous videos regarding unit conversions in dimensional analysis, we never start with a conversion term unless we necessarily have to. We have a term that is by itself. So we are going to start with this guy here, right? It is by itself. So let us write down our t-tables, right? So when we write down a t-table, right, we can write that down. We have our 213 grams of MgCl2. And it's very important to make sure you do write the identity of the compound you're working with, because notice the percent, it has both pieces, right? So magnesium and magnesium chloride, right? Elements and compounds. So we need to specify. The next part is 25.5 grams of magnesium will be on top, and 100 grams of MgCl2 is on bottom. Now, why did I write the conversion there and not try to flip it? Well, the big idea is, remember, units have to be opposites of one another, right? In order for them to cancel. So being that MgCl2, that is the unit we're looking for. It is opposite of our other unit here. So we can see that, all right, these are going to cancel. And even the better part is that this is going to leave us only with mass of magnesium, which is what we wanted from the problem. So when you put this in your calculator, right, 213 times 25.5 divided by 100. And that will give you your final number of 54.3 grams of magnesium, right? So that would be your final part. This is our answer here. So on to the next part. Percent yield. Percent yield is a common concept found within the laboratory environment. When you're doing an experiment and you are making a compound after a long day experiment, you're going to weigh it. When you do that, you will get an actual mass, which is referred to as your actual yield. Now, did you do a good job when you made it? Who knows, right? But there's a way you can tell. If you do stoichiometry, you can actually calculate the theoretical yield, or the number that you're supposed to get if everything goes to plan and is perfect. So if you take those two numbers, actual times or divided by the theoretical, and times that by 100%, you will get a percent yield. So let's try this with a certain problem. We'll make it simpler, take out the stoichiometry. If you have 34.2 grams of copper fluoride are actually formed in lab, and you calculate the theoretical yield to be 47.5 grams, what is the percent yield? When you are going through this, so we lay it out just like the problem we had above. we have our actual and theoretical, so we have to map out every number. One thing that we'll see, the actual yield is equal to 34.2 grams. Then we also have that our theoretical yield is equal to 47.5 grams, right? We have all these values in our problem. So let us set it up. When we are trying to get our percent yield, we're going to plug these numbers in to our equation here. So actual over theoretical. So we'll take our 34.2 grams, divide that by 47.5 grams, and then we will times that by 100%. When we are to do that, we are going to get a value of 72.0% as our percent yield, which is pretty good for a first-time experiment, especially when you're in general chemistry. The closer you are to 100%, the better you did, but there's always going to be some errors along the way, which is perfectly okay. You just have to think about it and analyze it. All right, on to the next type of problem. If the percent yield is 82.4% and the theoretical yield is 9.34 grams, what is the actual yield? So doing another percent yield problem, but the opposite. So in this case, we have 82.4% is our yield, and we're given the theoretical yield. And if you remember, that's on the bottom of our denominator. So let's set that up. 9.34 grams, and this is all times 100%. We want to know what the actual yield is. So let's do the math. First thing, just like our original steps from earlier, the very beginning of this video, divide by 100. Notice how that's the first thing we will do. So when we divide by 100 on both sides, you will get 0.824 is equal to the actual yield divided by 9.34. Our next step, we are going to multiply 9.34 grams by each side. That's going to cancel out terms, right? So let's show how the other ones are going to cancel too. We'll divide that 9.34, multiply it by each side. And what we will get is our actual yield, and that is going to be a number of 7.696. Okay, so actual yield is 7.696 grams. Now keep that in mind, write your units. Now, is that the right answer? Well, sig figs, right? So everything in the problem was 3 sig figs, so we have to make sure we round this to 3 significant figures. When we do that, our final answer is going to be 7.70 grams is our actual yield. And that's how you can do a longer version of this problem when you're not given every little piece. You know the yield, but you need to calculate a missing piece. Okay, on to the next. On to our last problem. We have solutions and density. In this case, what we are trying to do is find the volume of a solution, which is a mixture of different compounds together. In this case, we have a boba tea solution. So we got boba and tea and sugar and water all mixed together. When you have a solution, it's all percents, right? We have the part over the whole. In this one, what we're trying to do is find the volume in milliliters of a boba tea solution that is 15% of sugar, right? There's that conversion term. And that says by mass too. And it contains 79.2 grams of sugar with a density of 1.04 grams. We have all these important terms. Our first piece, which is percent. So we have 15% of sugar here. So if I have 15% sugar, that's the same thing as saying that I have 15 grams of sugar all over 100 grams of solution. Our next part, which was our sugar itself, is 79.2 grams of sugar, and that is a term by itself. Our last term is the density, where what we have is 1.04 grams of our solution all over 1 milliliter of our solution, so the density of it. Now, how do we go through and do this problem? Well, just like any dimensional analysis problem, we will write out our t-table and start with the term that is by itself. So the term that's by itself is the sugar, right? we'll start with that. And with that, it'll help us lead our unit cancellation, grams per sugar. We can use our percent to help us do that, right? You can see grams per sugar in that percent. So if I put the percent portion on the bottom here, where I have my 15 grams of sugar, 100 grams of our solution on top, notice how the grams of sugar will now officially cancel out as a result. Our next portion is, all right, well, use the density, convert it to milliliters. We have that 1.04 grams of the solution is equivalent to 1 milliliter of that solution. So that will cancel as well. Grams cancels grams. When we go through that process, we are going to do our last step. So 79.4 multiplied by 100. Then we will divide everything on the bottom. When we do that, we're going to get a final number of 507.69 milliliters. Now, as always, is that the correct amount of sig figs when you're going through this? When you are trying to go through these, right, we can see that we need 2 sig figs due to the percent. So how would we round this? Well, we got to round that to the second sig fig spot. So what this is going to round to is approximately 510 milliliters as our final solution. So I hope that this video helped. I went through many different examples of how you can see percents in chemistry. There are other ways that you will see them, but this covered all the basic areas that you could see them. Just remember 2 things. Percent is out of 100. And if you remember part over the whole times 100%, you will be able to solve any of these types of problems. I wish you the best of luck as you go through these, and I'll keep rolling out videos. And please hit that like and subscribe button if you like this and if it helped you. And hopefully this will help you pass chemistry and further even ace it, which would even be better. I will see you next time. Until later, this is Dr. Dan. I'll see you all later now. Bye.